Hello everyone, this is Dr.K.Kavita, working as Associate Professor in Department of Mathematics, BVRD, Hyderabad College of Engineering for Women. Today I would like to tell about that ordinary differential equations and vector calculus course, which is there in the BTech first year, second sem. So in this course, the syllabus is divided into 5 units. Unit 1, first order and ordinary differential equations. Unit 2, ordinary differential equations of higher order. Third unit, Laplace transformations. Fourth unit, vector differentiation. Fifth unit, vector integration. Let me start with unit 1, first order differential equations. So in this, the contents are differential equations, exact, non-exact differential equations, linear Bernoulli, orthogonal trajectories, Newton's law of cooling, growth and decay are the applications. And first we'll see the differential equations introduction. Let me start with the differential equations explanation, first introduction. We can say, take that the y equals to f of x, this is the function. We are differentiating on both sides with respect to x. We'll get that first order y dash. And again, we'll differentiate with that second time. We get that the second order. Containing the same, we'll get that nth term of the nth order derivative of the given function. We'll see that the definition of differential equations. An equation which involves a differential coefficient is called differential equation. Example, d square y by dx square plus x square into dy by dx plus y equals to 0. And these differential equations are two types, ordinary differential equation and partial differential equations. And one thing we need to note that what's the differential equation contains that two different variables are there, especially in ordinary differential equations. So when you see that in the numerator, y is the dependent variable we have to take, and the dependent denominator, we have that one more variable which is called independent variable. So we can tell about that y depend on x, y is a function of x. Now the difference between ordinary differential equations to partial differential equations. Ordinary differential equations, only an equation is said to be ordinary if one or more variables are differentiated with respect to one and only independent variable. Then it is called ordinary differential equations. And here differential operator is a d by dx plus y equals to 0. And we can move to the partial differential equation. A differential equation is said to be partial if the derivatives in the equation have reference to two or more independent variables. Then it is called partial differential equation. Here the differential operator is a dou y by dou x plus dou y by dou t equals to 0. We can say that the first topic and first unit, exact differential equations in first video, and the next coming video is non-exact differential equations. First, we'll see that the definition of exact differential equation, and differential equation is in the form of m dx plus n dy equals to 0, where m and n are functions of xy. Then it is called an exact differential equation if dou m by dou y equals to dou m by dou x. Then only we can take it out the exact differential equations. And we can take that this equation as a necessary and sufficient condition. And every model we need to get the solution. So that solution is in the form of general solution for exact D. And here we can take the two terms in NHS side. In first term, while you are doing with the integration, we have to take it out of y as a constant. While you are doing the second term, we have to free from the x variables, and that equals to c. And we can move to this is the algorithm for exact differential equation, which is in the form of m dx plus n equals to 0. In step 1, we are identifying that m and n. In step 2, we are differentiating with respect to y and n partially. Step 3, dou m by dou y, dou n by dou x should be equal. And fourth step, we are getting the general solution. And we can observe that here m terms are given four different examples. N terms and second term, we have that 4 different examples. And especially we can concentrate here, x is not here, which is free from. If x terms will be there, we are not going to consider. Only y terms we have to consider. An example. First example, 3x minus 2y plus 5 into dx plus the 3y minus 2x plus 7 into dy equals to 0. And we identified which is in the form of m dx plus n dy equals to 0. Now, the first term we are differentiating with the m dou m by dou y equals to minus 2 we got. And the second term we are differentiating with respect to partially dou n by dou x equals to minus 2. And hence both are equal, then this is exact. After exact, we need to get that general solution. So what's the general solution here? The general solution is m dx plus integration of n terms of terms free from x into dy equals to 0. When you integrate this, we have to consider that y terms are constant. So that y term is a constant. That's why dx will be that x you are getting, and 5 is also constant here, 5x. And here x terms will be free. So that's why here there is no x term, and we are integrating with respect to y, and we got this answer. So we can say that the second example also, x cube plus 3xy square dx plus y cube plus 3x square y dy equals to 0. Identified m dx plus n dy equals to 0. We differentiated with respect to y and x, and we got exact. And we did that the general solution, keeping that y constant in first term, keeping x is free from all the variables, and we got this answer. So these are all the 5 examples, and 5 different answers will get the students solve these 5 problems as a homework. In next video, we'll see that non-exact differential equation, which is in the form of dou m by dou y is not equals to dou n by dou x model. Any queries?